Have you ever wondered if the hands of technology touched vehicles, what would happen? Or maybe you're asking yourself if there is truly a new mode of transport that moves faster than anything we already have, or even safer, lower cost, immune to weather, resistant to earthquakes, and self-empowering. Let me inform you that Elon Musk is here to answer your questions by inventing a train with all these qualities. The first of its kind, the Hyperloop. In today's video, we'll take a closer look at the Hyperloop, bringing the spotlight to every detail of this invention. But before we start, make sure to subscribe and hit that bell to turn on notifications. Let us start by knowing what a Hyperloop is exactly. Hyperloop is an ultra-high-speed ground transportation system for passenger and cargo proposed as a concept by Elon Musk, CEO of Tesla and SpaceX, in a white paper back in 2013. The system consists of a sealed and partially evacuated tubes, connecting mobility hubs in large metropolitan areas, and pressurized vehicles, usually called pods, which can move at a very high speed thanks to the contactless levitation and propulsion system. That door-to-door travel time on medium-range distances can be considerably reduced compared to current connections. Moreover, with fully electric operations, the system aims to be climate neutral. The question here is, where did this idea come from? The VAC train concept was first proposed by Robert H. Goddard in 1904. The concept was also depicted in the 1973 movie Genesis 2. Where an elaborate sub-shuttle subterranean rapid transit system was constructed to interlink cities and continents. Musk first mentioned that he was thinking about a concept for a fifth mode of transport, calling it the Hyperloop, in July 2012 at a Pondo Daily event in Santa Monica, California.
And I have a name for it, which is called the Hyperloop.
The Hyperloop?
Hyperloop, yeah.
Is it like a Jetsons tunnel?
It's something like that, yeah.
This hypothetical high-speed mode of transportation would have the following characteristics: immunity to weather, collision-free, twice the speed of a plane, low power consumption, and energy storage for 24-hour operations. The name Hyperloop was chosen because it would go in a loop. Musk envisions the more advanced versions will be able to go at hypersonic speed. In May 2013, he likened the Hyperloop to a cross between Concorde and Railgun, and an air hockey table. From late 2012 until August 2013, a group of engineers from both Tesla and SpaceX worked on the conceptual modeling of Hyperloop. An early system design was published in the Tesla and SpaceX blogs, which describes one potential design, function, pathway, and cost of a Hyperloop system. In this alpha paper, Elon Musk set out the case for a service running between Los Angeles and San Francisco, which would be cheaper and faster than a proposed high-speed rail link. He also said that a Hyperloop service could be the answer to travel between cities less than about 1,500 kilometers or 900 miles apart. Beyond that, supersonic air travel would be more efficient, as he said. He also once wrote, "Short of figuring out real teleportation," which would of course be awesome. Someone please do this. The only option for super fast travel is to build a tube over or under the ground that contains a special environment. Nobody has gotten very far with the teleportation idea, but a number of companies have seized on the potential of Hyperloop. Now let's take the system of the tube itself. It's a large diameter tube laid in the ground between the start and the end points of the route. It operates a capsule with passengers dubbed a pod. The tube has conditions similar to a vacuum, which almost eliminates air resistance. During movement, the pod levitates, which in turn reduces the force of friction. As a result, the capsule is able to move faster than a plane, at a speed of more than 1,000 km per hour. In fact, the acceleration of the pod to a specified speed and the creation of a vacuum make up the main technical task the project engineers have been toiling over. It is important to understand that the smallest error by the developers can lead to terrible consequences at breakneck speed. It's worth noting here that, according to Musk's base requirements, Hyperloop should run solely on renewable energy, which is another headache for the experimenters. So shortly after SpaceX and Tesla Motors developed the first Hyperloop concept in 2013, the owner of these companies addressed the public, calling for efforts to improve the Hyperloop. Since then, research and experiments on Hyperloop technologies have been carried out in an open source mode, where all developers freely share their findings with partners on the project. At that time, two companies were created to continue the developments: Hyperloop One and Hyperloop Transportation Technologies, HTT. The latter now brings together about 800 engineers from the United States who are currently working on the project for free, hoping to receive dividends after its implementation. HTT has already evolved into a social movement, whose goal is to create a single word where distance has no special importance as the result of a Hyperloop network spreading across the continent. Based on the description of the future infrastructure project, it is obvious that the main, the longest, most critical and costly elements of the Hyperloop will be the tube. The material from which it will be manufactured should be able to create a vacuum environment inside the structure, guarantee the safety of the capsule traveling at high speeds, and withstand all weather and environmental challenges. Also, given the long length of the future transport infrastructure, on the European continent alone, Hyperloop will extend for 10,000 km. An important factor is the well-established manufacture of tube material and the relatively low cost of its production. Teams working on the Hyperloop have explored a great number of possible materials for its construction. At the current stage of the project, the scales dealt in favor of steel. Concrete was rejected because of its relatively low strength and difficulty in achieving airtightness. Aluminum, which is one of the main materials in the aircraft industry, was rejected because of its lesser rigidity, while an acrylic tube would have been unreasonably expensive. The researchers are now busy studying the various forces that will impact the steel tube of Hyperloop in the future. So far, they can only simulate the impacts of the difference in air pressure inside the tube and the air environment outside the structure. Thus, the calculations of the experimenters show that, with the steel tube radius at a preliminary 1.75 meter, the thickness of the Hyperloop wall should be 25 mm, since a thinner wall will not be able to withstand the buckling due to the internal stress caused by the vacuum. These challenges force Hyperloop developers, just like their fellow aircraft builders, to look to modern composite materials. First, composites are lighter than steel. Second, due to specific manufacturing features, composite tube walls will be thicker than the steel walls, which significantly will help find solutions to the buckling problem of the Hyperloop. Third, composites are not as sensitive to temperature fluctuations, therefore, the risk of thermal expansion will be much lower than with the steel tube. Fourth, the use of composites allows for the manufacturing of a long tube, thus reducing the number of joints. About the Hyperloop capsules. In Musk's model, the capsules float above the tube surface, on a set of 28 air-bearing skis, similar to the way that the puck floats just above the table on an air hockey game. One major difference is that it is the pod, not the track, that generates the air cushion in order to keep the tube as simple and cheap as possible. Other versions of Hyperloop use magnetic levitation rather than air skis to keep the passenger pods above the tracks. The pod would get its initial velocity from an external linear electric motor, which would accelerate to its high subsonic velocity and then give it a boost every 70 miles or so. In between, the pod would coast along in near vacuum. Each capsule could carry 28 passengers, other versions aim to carry up to 40, plus some luggage. We know you're about to ask yourself how this Hyperloop could be powered, and we are here to answer all of your questions. An eco-friendly version of the Hyperloop network is in the works, powered by a skin of solar-powered modules and wind turbine forests, and complete with parks and urban farming spaces. The new sustainable design by Chinese architect MAD is made in collaboration with Hyperloop Transportation Technologies and aims to create enhanced connectivity between cities and people. The team says. The transportation tunnel, MAD says, will be fitted with bendable solar panel skin modules that will power the Hyperloop itself and interactive information board. Meanwhile, bladeless wind turbine forests will also be built along the Hyperloop system, a move the designer hopes will generate power for the transportation network and lower the project's energy cost. In comparison with a train, supporters argue that Hyperloop is significantly better than a high-speed rail. It is lower cost and more energy efficient because, among other things, the track doesn't need to provide power to the pods continuously. And because the pods can leave every 30 seconds, it's more likely an on-demand service. It's also potentially 2 or 3 times faster than even a high-speed rail, and 10 times the speed of regular rail services. So how much do you think a Hyperloop would cost to build? For the LA to San Francisco Hyperloop that Elon envisaged, he came up with a price tag of under $6 billion. Spreading the capital cost over 20 years and adding in operational costs, Musk came up with a figure of $20 plus operating costs for one-way tickets on the passenger Hyperloop. If you are curious about what it feels like to travel in this super fast vehicle, the answer is here. Critics of Hyperloop have warned that traveling in the tube might be an uncomfortable experience due to nausea-inducing acceleration, plus lateral g-force on bends in the route. However, version Hyperloop 1 says that the journey via Hyperloop will feel about the same as riding an elevator or a passenger plane. Additionally, the first passengers on version's Hyperloop, Josh Giggle, Hyperloop's co-founder and chief technology, along with Sarah Lucian, the co-founder and technology officer, described as, "This is going to be smooth, that if you drink a cup of coffee, you won't spill it." And it was smoother than expected. It was easy, it was quiet, it was great. Apparently, it's a breathtaking experience and the best yet that one can ever try. And don't you think that to get somewhere that quickly is a game changer? What about you? Are you excited about it? And would you travel in it when it comes out? Let us know what you think about this Hyperloop in the comment section below. See you in the next one. Take care.